Alright, good day, peoples. We are going to go over solving linear inequalities, or in your book, chapter 8.2 is actually called the algebra of linear inequalities. Now, we briefly went over the inequalities in class. Remember, you have your less than, you have your greater than, you have less than equal to, and then remember you have your greater than equal to. Now we need to remember all of these for when we get to graphing our solved solutions. We need to graph them. So nevertheless, if I have the set or the equation of linear inequality, shall I say, 3x plus 7, which is less than 16. Now here's the deal. The key is you solve inequalities the same way you will solve for a regular equation. So the first thing I would do was subtract the 7 from both sides, which now leaves me with 3x is less than, guess what, 9. Because again, we're doing 16 minus 7. Then what's left to do? You love to do it. Divide everything by 3, and x is less than 3. If we need to graph this, well, this is 0, this is 1, this is 2, and this is 3. Again, since we discussed it in class, since this is just less than, that means it is open at 3, and then we shade everything in the direction of the inequality, which is to the left, which means less than. And then we've done our first solution. Another example. Since you love them, I have negative 2x is plus greater than equal to 21. So, if I want to solve for this inequality, again, you do the same steps as you would to solve the equation. So subtract 1 from both sides, and I get negative 2x, which is greater than equal to 20. Now here's a catcher. Anytime you divide by a negative number, flip the inequality. So now I have to actually divide by a negative 2. So now this inequality will no longer be greater than. It'll now have to be less than. So x is now less than equal to negative 10. And then we solved our solution. If I need to graph it, again, we draw a number line, and we start here at 0. And negative 10 will be on the left side of the number line, so we go down 10 increments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully I counted 10 correctly. So we start at negative 10, and since again we're looking at our inequality and it's telling us less than equal to, well, that means less than equal to. The equal to indicates that it is a closed circle, right? And then we still shade everything to my left. And then we have solved the solution, or graphed the solution. Okay? We also talked about using the distributive property while we were solving for equations. So, let's say for instance I have negative 7 times 2x plus 1, which is less than 1. Well, in order to solve, before I can solve for anything, I must distribute the 7 to everything in the parentheses to its right. So that gives me negative 14x and a minus 7. which is less than 1. As I proceed to solve, I add the 7 to both sides, and negative 14x is less than 8. What's left to do? You've got it. Divide both sides by negative 14, and now x is greater than 8 over negative 14. Now, do we understand why I flipped the sign? We flipped the sign because we ended up dividing by a negative number. Now, can I reduce 8 over 14? I'm sure that I can. I can reduce it by at least 2. 2 goes into 8. How many times? 4 times. And 2 goes into 14. How many times? 7 times. Technically, we really don't write that negative number at the bottom. We kind of bring it to the top. So my final answer for this will be x is greater than negative 4 over 7.